welcome back to, I guess, rational functions continued. And in this case, I'll take on kind of a special case. It's one of the easier cases for rational functions, and it is one that we should be pretty comfortable in trying to sketch out in general. So it is just f of x is equal to ax plus b, and so that's order 1 in the numerator, and then another order of 1 in the denominator, which is cx plus d. So if you were sketching this, now of course a, b, c, and d, so those ones are just some numbers, okay? So it could be a rational number. Now we do have to be careful a little bit. You obviously can't have c and d equal to 0 simultaneously, okay? And then if a and b equals to 0 simultaneously, well, then that's not really much of a function there as well. So what I'm going to do is I'm going to try to break it down and kind of get rid of, in some particular cases, first, and then we're going to try to sketch it for the more general cases. So first of all, we're going to kind of make the assumption that our c, for instance, is not going to be equal to 0. So that's the first thing. Because if it was equal to 0, so notice if you set it to 0, then that means c times x is 0. And then all you have is ax plus b divided by d. And since d is just some number, then we just have a line. All right, so then it just becomes our regular slope and y-intercept, and then we can plot it from there. All right, so if that's the case, so maybe what I'll do is here I'll say if c is equal to 0, then really we're just dealing with f of x just being a line. And I'm sure that by now, since you're studying advanced functions, you are pretty comfortable in trying to graph these lines. So that's the first case. Now, the other case, which is also relatively simple to do because you have done so many transformations, is when we have the case when a is equal to 0. And in this case, what you're going to have f of x is equal to, and then this is just going to be b all over cx plus d. Now, in this case, I'm going to kind of take out the c from the denominator. So what you would have is, really you would have this. You would have b all over c, right? And then you would have 1 all over. So I'm factoring out the b from the top and then c from the bottom. And then what you have is x, okay? And then it would have been plus d all over c, okay? So that's what you would have. And in this case, so we know, okay, so this right here is just basically a stretch or a compression in the y, all right, from our parent function. And then our parent function for this instance, so if you take a look at this, the parent function is just 1 over x. And we know exactly how that looks like. So here is your stretch or compression. And then this right here, this d over c, is basically just a shift, right? So it just shifts left to right. So that one is also relatively simple to do. So for instance, if I take a look at an example of this, and I would say, so here is an example of the case when a is equal to 0. So let's say I have something like this. I would have maybe 2, right, all over, so this is my f of x, and then let's say this is 4x, okay, minus, I don't know, let's say 8, okay, so something like that. Now, if I'm going to try to graph it, okay, and sketch it out, so what I would do is I would say, okay, well, I have 2 all over 4, right, and then I'm going to have 1 all over, and then since I took out so this is going to be the 4 from the denominator, it's going to be x, and then minus, I guess, is going to be 8 over 4, which is 2. So this is what I have. So this right here is just a half, right? Okay, so that's what I have. It's between 0 and 1. So it's going to be some kind of a compression that I have in there. This right here, so from this right here, so that means this is going to be a shift, 2, okay, so 2 over. So I have a translation, okay, to the right. And if I plot my parent function, so this one right here, so what I would have is, so let me graph it out in here. So this is, okay, what I have. So this is my 1, right, over x. So we know that it looks like this. okay, and it has, so basically right here, so this is your vertical asymptote, okay, right here. This is your horizontal asymptote, right? Okay, so this is what we have right there. And now if I wanted to be able to take this, so let's write, so this one, so a half and then 1 over x minus 2, so that's going to shift over, so it's going to be shifting over, so this is now my new vertical asymptote, right? And then it shifts over, it kind of gets compressed, so kind of looks like this, and then this gets shifted over here. So that would have been my sketch. I still have my horizontal asymptote in this particular direction. And so here, let me just show you when we have, oops, it's not what I wanted. There we go. Okay, so if I put this and my, f of x is equal to 1 over x, so here it is. Okay, so that's my parent, and then, let's say I'm going to put g of x is equal to, and this was, I guess, 2 over 4x minus 8. All right, so notice that it's the blue. Okay, so it got shifted over. Notice the vertical. All right there. And then it kind of gets a little bit of compressed there. Okay, so that's what we would have, okay, in here. Now, that's when the case is when you have a is equal to 0. Okay, so now in general cases, so now if let me swing this right out. So if I'm dealing with this in general, so like what characteristics do we have in here that we should know and understand? All right, so what happens in here? Well, so first of all, okay, we know quite a bit. This is of order 1 in the numerator and then of order 1 in the denominator. So under kind of special cases, you might have a hole. You know exactly where your vertical asymptotes and horizontal asymptotes are, right? So we talked about those with respect to rational functions just in general. So I'll put up a link up above there, right? But in this case, we can certainly figure out all of these. So when do we have, so in this case, if we have vertical asymptotes, where are they? Well, this is the case when cx plus d is equal to 0, right? So if I would work this out, so this is going to be, so I guess negative right there. So that's where your vertical asymptotes are. Now, of course, the assumption is that at that particular point, your numerator is not equal to 0, right? Okay, so that would have been your vertical asymptote. Now, what happens if, I would take the numerator, so I would take ax plus b, and I would set that equal to 0, right? And then I would get, so negative b over a is equal to x. If it turns out that these two are equal to each other, then you will remember from using the rational functions and graphing, so that's going to be resulting in a hole. And if we do have a hole in this case, this is actually going to be a kind of a flat liner, all right, if these two are equal. So these two are particularly equal. So what do I mean by that? Let me show you an example. So let's say my f of x right here is equal to, let's say this was x plus 2, all right, so my, so from here, I know that x is equal to negative 2, so that would have been a 0 for the numerator. And then let's say this is, I don't know, 4. I'm going to kind of, cheat here a little bit. 4x plus whatever, 8, okay? And then in this case, what would we have? We would have x is equal to negative 8 over 4, which is still negative 2. So notice these two are equal, right? And because these two are equal, then what you would have is you're going to have x plus 2 all over. Let me take out the 4. So you're going to get x plus 2 again. Okay, so there you have it. So here's my hole. So it's going to be at negative 2. And now these two, of course, cancel each other off. So for all other values of x, so at x is equal to -2, it's not defined on that domain, right? We have a hole, we're going to have a hole there. But for the rest, it's just a flat line. So if you were graphing this out, so it would have been interesting because, you know, so at here, so what you would have had is, I guess this is what at -2. So let's say this is -2. So we're going to have a hole at -2. And, you know, so here is your graph. It's just a flat line all the way, right? And this is at 1/4. So that's what would have happened with that. And what I was mentioning here is that if these two are not equal, right? If you do not have a 0 in the numerator at the same value as in the denominator, then you have a vertical asymptote, right? So that's what would have happened there, okay? So now these vertical asymptotes obviously now tell us, okay, that, you know, something is going to be happening as we get closer and closer. It's going to be approaching it from the right or left or whatever it might be. And then the other part is that in these instances, so for this, let me copy this, bring it down. You know, what else can happen in here? Well, your horizontal asymptotes, okay, so notice as x gets really large, so if x approaches infinity, so it gets bigger and bigger and bigger and bigger and bigger, right, then this entire thing is going to tend towards a/c. And that's going to be your actually horizontal asymptote, all right? Okay, so that's what's going to happen. And of course, if x, you know, approaches negative infinity, so if it gets, you know, bigger and bigger and bigger, but from the negative side, now, so if you substitute it back into here again, you're still going to get a/c, because the x's are just going to be negative, but they're going to cancel. And this b and d, they don't really play a role because they're fixed, right? They're just fixed numbers. And if you make x be bigger and bigger and bigger and bigger and bigger, you know, eventually it approaches a/c, which is your horizontal asymptote. Okay, so that's your horizontal asymptote. So we can find the vertical and the horizontal asymptotes pretty quickly, and then we can start graphing and sketching it out. Okay, so this is a very special case, and you can actually plot these on your own without using decimals or anything, okay, for that matter. So let's take a look at an example just to let me show you. Okay, so what happens? You know, we've dealt with the special cases, but what if we have something which is, you know, not too nice? Okay, so let's imagine we have this. I have, I don't know, -2x plus, let's say 3, right, all over. And then, so just randomly, okay, and I'm going to put here, I don't know, -x, okay, plus, let's say 7. All right, so this is my rational function. So it's clearly of order 1. Okay, let's see what happens. So if I do this, what I notice, so right here, this is going to be x is equal to, and I guess this is going to be x is equal to 7, right? So that's my 0. So that's going to be my vertical asymptote, okay, for in here. Now, if I plug in 7 into the numerator, so -2 times 7 is going to be -14, okay, plus the 3. So clearly it's not 0, all right? So I do have a vertical asymptote here. So I'm going to try to sketch it for you, just so that we can see what happens. So in both direction, okay. So let's say, okay, so this is x is equal to 7, so we know we have an asymptote there, vertical one. Okay, so that's fine. Now, do I have a horizontal asymptote? I do, indeed. So if x gets, you know, really, really, really large, notice what we're going to get, okay, from here. Actually, let me highlight this. Okay, so that's going to be those leading coefficients, so -2 over -1, which is just 2. So we're going to get, so in here, so that's going to be my horizontal, and that's going to happen at 2. All right, so now I have my horizontal asymptote, and then I have my vertical asymptote, so those are it. Now, what happens through the rest, right? Okay, so what happens in this case through the rest? So we want to be able to kind of graph it out. Now, the end result, so if you go, further out to the right, okay, so as x gets, bigger and bigger and bigger, notice that we know that we're tending, okay, towards 2. So we're going to be tending towards 2. Now, in which direction? Is it coming from the bottom or is it coming from the top? Right? Is it coming from the bottom or is it coming from the top? So an easy way to check this for yourself, so if you wanted to see, if it's, and this is what I mean, is it going to be going something like this or is it going to be something like this, right? So this is what we want to know. All right. So in order to do that, so I can certainly substitute. So I'm going to, let's say, substitute a very big number. So let's say 1,000, all right? Or even 100, but let's put in 1,000. Okay, plus 3 all over. This is something that you're going to be just kind of checking for yourself. And then plus 7. All right. So notice what happens here. So you have in the numerator, so it's going to be negative 2,000 plus the 3. So that's going to be around 1, I guess 7. And then in the denominator, what do we have? We have, so this right here, so that's going to be negative 1,000 plus the 7. Okay, so that's going to be negative, and it's going to be, I guess, 3. Okay, so in this particular case, so what are we noticing in here? So if I, plug this back into my calculator, so the negatives will cancel, but I'm going to get 1,997 divided by 993. So notice that it is a little bit more, and it should make sense because 993 is smaller in magnitude. Okay, so it's a little bit more than 2. So it looks like, okay, this thing is coming from the top, right? So it's going to be coming from the top and getting closer and closer and closer towards that asymptote, all right? Okay, so now once you know that, and because that's the asymptote, so now we can actually kind of sketch this out. So most likely it's going to be something like this because it's coming in, right? Because it can't cross the vertical asymptote either. Now, what you can do is, because you know the vertical asymptote is at 7, you can, if you want to just double check for yourself, okay? So in this particular case, where is it going? So my guess it's going to be that it's going to be something like that. But you never know. Maybe maybe it kind of goes like this. It overshoots and then comes back like this, right? So that's something that you have to check for yourself. So let's see, as you get closer towards 7. So I'm going to, let's say, we would plug in here. So try to get it, to as close towards 7, but just on the right-hand side. So let's say if I would substitute something along in here, what would the answer be, right? So now if I substitute it back into here, what would that give me? So, all right, let me kind of do something like this. So it's going to be negative 2. Substitute this in here all over. This is going to be negative 7.01 plus the 7, right? And this is what we want to be able to see what it gives us. Okay, so fine. So I'm going to substitute all of this in. So negative 2 multiplied by 7.01 and then plus the 3. So that is my numerator. Then that's divided by, putting it all in brackets there. So the denominator, so minus 7.01, plus the 7. So we know it's going to be that. Okay, and notice that it's a very big, large, positive number. So indeed, it looks like it is going upwards there. Okay, and then it comes down in here. So it's going to be something like this. Okay, now on the opposite side, so just, just on this side right here, like, what's going to happen, okay, in this case, and then what's going to happen, okay, as you go further and further to the negative side. So you make those large numbers bigger. So my guess, so this is just my guess through my experience, is going to be that this is going to look something like that. But again, you can just check it by just substituting in very close to 7 and then a very kind of in magnitude, a very small number. So going all the way to the left to C. So let's plot it out to check if we actually sketch this correctly. Okay, so so this is my sketch. Bring back Desmos. Let's now put this back in here. So what did we have? We had, I'll put it in brackets in here. So -2x plus 3 all over. That's -x plus 7. All right, so that's what we have. Okay, and notice what happens. So indeed, it looks like our sketch that we wanted. And as you get in here, it gets closer and closer towards 2, right? From the upper side. Okay, you can see that there. And then on this side, notice that it comes up, again, it gets closer towards 2, but now from the bottom up. So there you have it. So that's the sketch. It's kind of how you can use these sketches with these rational functions. And, so it's a special case, but sometimes you may study this in advanced functions, and it's something that you should kind of be aware of, right? It definitely will look more or less like your parent function of 1 over x in general. So that's just a hint for yourself. All right, so hopefully those examples help. And it gives you a sense, on what to think about in terms of horizontal, vertical asymptotes, maybe a hole, okay, somewhere that you have like this. And, you can try those out for yourself to try to plot. Okay, thanks for watching. See you in a future video. Bye, everybody.